As we approach the end of our Keystone review, we're going to go to number 81. Now in 81 I see 4 graphs that we need to pick from. So I'm going to write down these 2 equations on my work over here. So 2x is greater than or equal to y minus 1. We really need to get y by itself, so we need to add this 1 to the other side. That's going to give us 2x is greater than or equal to y. I'm sorry, 2x plus 1. Now, this equation is written backwards. We want y to be first. So we're going to take this y, we're going to read this as backwards. So we're going to do less than or equal to 2x plus 1. So we switch the sides of the equation and reverse the sign. Hold on to that. Now for the second equation, 2x minus 5y is less than or equal to 10. We have to get this y by itself. So we need to take over this 2x by minus 2x. Bring down the negative 5y less than or equal to. Please put the minus 2x first and then the positive 10 behind it. Divide everything by negative 5. You will have to remember that when you divide by a negative, you will need to flip your sign. Divide by negative, flip sign. So that's going to be a positive y. You're going to change this to a greater than or equal to a positive 2/5 x, and that makes a negative 2 when you divide. Let's graph. I will graph this one in orange. So the first thing we do is go to positive 1 and make a dot. Then we use our slope to go up 2, over 1, up 2, right 1. You need to connect, but you will connect with a solid line. And the reason you connect with a solid line is because of the equal to part. You will shade, this says less than, so you will shade below this line. Okay, now for the other one. I'll graph it in purple, or black, because that's the marker I got. So go down to negative 2 and make your first dot. Now go up 2, right 5. Up 2, right 5. Connect using a solid line because it's equal to. Shade above this line because it says greater than. Do you see the spot where it overlaps? That's where your final answer is. So I'm going to go back here and I want to find that answer. And I see the only one that has the correct answer is right here, C. I'm not going to write on this, so I have extra paper to practice. 82. Which ordered pair is a solution to the system of equations below? You have a few options here. Probably what's going to be best for you guys is to try this as x and to try this as y and plug them in and see if you get a true statement. So we have x and we have y. We have x and y, x and y. There is another way to do this, but for right now, let's just practice putting it in your calculator. So let's write use calculator, plug in. Okay, so let's see if I can eye up the right answer. I'm not sure if I'm fast enough to be able to do that. Be negative 2 minus b. Okay, I think it's D, and I want to show you why I think D is the answer. So if I plug this in for x, I will get 16 plus 3 times, I'll plug that in for y, and let's see if we get negative 7. So I'm trying D. 16 plus 3 times negative 3. That does give me 7. Now let's try the bottom equation. Let's see if we get 10. We do get 10. So that one does work, so that one is the answer. There is another way to do this problem, and it's what you learned in Chapter 6 with Mr. McBurney or Miss Shirey. If you line them up like this, I'm going to write a big OR word here. If you multiply the top one by a, let's just do by a positive 2 and the bottom one by a negative 3, all I did was switch these two numbers here and make one of them a negative. You will get 2x plus 6y equals 14 and negative 3x minus 6y equals negative 30. When you add those, you end up getting negative 1x equals negative 16. And when you divide by negative 1, you end up getting x equals positive 16. So both ways work, and then positive 16 is the only one that actually does work. The calculator way using plug-in might actually just be the easiest for you. 83. Marcy has a total of 100 dimes and quarters. If the total value is 1405, how many quarters does she have? Well, you can make two equations from these, for example, dimes and quarters. So if we say the dimes and the quarters makes 100, that's a great equation. Now every dime is 10 cents, so put 0.10d, and every quarter is 25 cents, so put 0.25q. And that has to equal 1405. Now logically speaking, you should be able to sit here and figure this one out if you try hard enough. Okay, so we can take our options and plug them in, or we can just kind of like do math and figure it out from there. Let me see if I can eye it up first. Here's what I'm going to do. If this is how many quarters she has, that would have to mean that she'd have 73 dimes because it has to add to 100. Let's just try that. There's a quarter. There's a dime. That would make, oh, look at that. That was like the perfect first guess. That would make 1405. So I guess what maybe we need to think about here is that you could do this algebraically with those equations, or you could just say if she has 27 quarters, that would mean she would have to have 73 dimes because it has to equal 100. Hope you can't see that. So if I do 27 times 0.25 and I do 73 times 0.10 and add that together, I end up getting that 1405. So I know A has to be my answer. Now you could solve this using elimination, but I think that actually kind of works out well for us. Okay, let's move on to 84. Which of the following best describes the graph of this system of equations? Okay, so what we need to do, we need this to be equal to y, both of them. So number 84, let's see if I can slide this under here. Perfect. I like the first equation. It's y equals negative 2x plus 3. The second equation, I'm going to need to divide it by 5 in order to figure anything out. So divide by 5. You need to have it in y equals. You should know that from Chapter 5 of Algebra 1. Okay. These are literally the exact same lines. And if you don't believe me, go to the y equals button on your calculator and type in negative 2x plus 3 and negative 2x plus 3 And when you graph it, you'll see clearly that there's only one line because it's graphing it on top of itself. So 84 says, what's true? They are two identical lines. Let's take a look at 85. I'm going to write it a little bigger. This comes from your Chapter 7 skills. You have to reduce this. So 5 and 10 reduce. Hopefully you understand into... My headphones just had a really loud noise. 5 and 10 reduce. Hopefully you know into 1 and 2. And see how there's 3 x's on the top and 7 on the bottom? I would say to you the party's in the bottom. How many more? 4 more. You just subtract them, and whichever one has more, that's where the answer goes. So that answer would have to be B. Number 86. I see a minus sign here. This comes from Chapter 8. Okay, and I need to distribute that negative. So I'm going to write distribute negative. So it's going to be 4x squared minus 2x plus 8 minus x squared minus 3x plus 2. So that's going to be, let's combine our like terms now. It's going to be a 3x squared, a minus 5x, and a plus 10. That's the end of the story, and my answer is D. Don't rainbow the whole problem together, just put that negative in. Okay, see this negative right here? It needs to get distributed, which is what I did. 87. The sum of two binomials, so here's something and something, and that's going to equal 5x squared minus 6x. Okay, so it says the sum of two binomials is 5x squared minus 6x. If one of the binomials is 3x, oh look at that. If one of them is 3x squared minus 2x, what would this one have to be? Well, if I need to get 5x squared, I know I'm going to need a 2x squared. Does that make sense? Because it would be 3x squared plus 2x squared makes 5x squared. I need a negative 2 to become a negative 6. That means I'd need another minus 4x. So if you add this to this, you will get that final result. Therefore, the answer has to be A. Let's look at 88. Which of the following expressions is equal to all that stuff? I'm going to carry it over so I can write on it. Put your force fields on. And my hope is that you know you can't really do anything with this one right now, but you can, as you guys would say, maybe distribute or rainbow these ones together. So carry down the x plus 2. There's nothing special that happens with that one. Now let's rainbow this and this. So you get plus 2x squared plus x minus 4x minus 2 when you distribute. Combine your like terms. That's 2x squared. I see x and x, it makes 2 minus 4 is minus 2x when you combine, and the 2's actually end up canceling. This is my answer, so A is my only option. 89. A volleyball court is shaped like a rectangle. Well, if you guys don't know me by now, I expect you to draw yourself a rectangle. It has a width of x, and it has a length of 2x. What is the expression for the area? Well, this actually looks like something like you would have seen on a test. You know area equals length times width. So that's area equals 2x times x. So when you multiply, you just get 2x squared. The only option is B. Let's try 90. Number 90. What is the factored form of factoring? This is from Chapter 8, again, and they want us to factor it. So the first thing I'm going to look for is a GCF. Hopefully you remember that. And, oh, it does have a GCF of a 3. So let's pull a 3 out and see what we get. A squared minus 8ab plus, let's see, 3 into 48, I think that's 16. Ooh, and that has a b squared on it. Kind of weird. That's okay because you guys should be pros at the box. So AC is not this 3, it's 1 times 16. So 16. And the value of b is negative 8. So that's going to be, let's see, what multiplies to 16 and adds to negative 8? We have not 8 and 2. That's not going to work. 4 and 4. Negative 4 and negative 4 are the key numbers. Now draw your box. Put 1a squared up here. Put 16b squared down here. This is a great factoring problem. Put a minus, I wish this was bigger. Put a minus 4ab here. And another minus 4ab here. It is GCF time. On the way down, I'm going to pull out an a and a minus 4b. On the way over, I'm going to pull out an a and another minus 4b. They were kind of tricky with that b on there, weren't they? So my final answer is the 3 and an a minus 4b and another a minus 4b. Let's see, where do we see that answer? I think that is option C. 91. Another factoring problem. There is no GCF, so I can just do AC is 1 times 24. So 20, I guess I could write 24 here. And B is negative 11. So that's going to be negative 8 and negative 3. Those are the key numbers. Now it's time for our box. Put x squared up here and 24 here. Negative 8x here and negative 3x here. GCF is, not 8, x and a negative 3. GCF here is an x and a negative 8. So we have x minus 3 and x minus 8. Number 91 says which one of these is a factor? That has to be option B. X minus 3 is one of the ones that's listed. So they're not asking what both factors are, just one. 92. Which one of the following shows that completely factored? Well, I am going to note that there is no GCF. So that means I do A times C, which is 9 times 4, which is 36, and B, which is 12. My numbers are 6 and 6. Now it's time for your box. So please put 9t squared where it belongs, and 4 where it belongs. Put a 6t here and a 6t here. GCF going down is 3t. GCF going down is a positive 2. GCF going across is 3t. GCF going across is a positive 2. So that would be a 3t plus 2 and a 3t plus 2. So my option is A, because it would be the same thing twice. 93. Now number 93, we could do a box. And I don't know if you can see on my eraser marks, I actually did my box, but I actually find this one a little bit confusing. So what you might find more beneficial is I think the answer is B. I'm going to show you another way that you could approach these different problems. So let's pretend we know the answer is B, which I think it is, but let's see if we can prove it. You see how it's 8 and 2 plus z and 2 minus z? What I'm going to have you do is rainbow or distribute these binomials together. Keep your 8 out front though, okay? So it's going to be 4 minus 2z plus 2z minus z squared. Now let's combine our like terms inside. So we get 4 minus z squared. Can you see how the middle two terms cancel out? Now distribute in your 8 to get 32 minus 8z squared. You can see that that's our options because it multiplies back to what the problem was. So if you ever get stuck on your factoring, because I factored this and I had the right answer, but I wrote mine in like the order it should be written in, so none of mine answer matches theirs. So if that ever happens, just like multiply and distribute these things through and see if you can get the right answer. I will tell you this, many students might get stuck and think the answer is like D. Please do not distribute that squared in. That's a big no-no. You can't just distribute a square into a binomial to check it. 94. If x squared is added to x, the sum is 42. Let's write that down. If x squared is added to x, the sum is 42. Which of the following could be the value of x? Now you could set this equal to 0 and do the quadratic formula. I'm going to write that down. You could equal it to 0 and use the quadratic formula. But I promised you on the Keystones you should never have to use the quadratic formula. You should just be able to take your options, plug them in, and see which one's true. For example, let me see if I can do this in my head real fast. Minus 42, minus 7, positive 7. I think the answer is B. Let me prove to you how B is the answer. So I'm going to take this x out and I'm going to put in negative 6. And I'm going to draw my plus sign. There's a cat. Hi, Ben. Is the cat being helpful for everyone? Can you back up? Thank you. Okay. Thank you. All right. And so I took out this x and I made it negative 6. Now I'm going to take out this x and make it negative 6. Let's see if this is true or false. I think I might have got it wrong. I think the answer might be A, but let me prove myself wrong. That's okay. I've been wrong in the past. I'll be wrong again. I definitely don't get 42, do I? Let's try A. Maybe A is the answer. Yeah, that would make more sense. Let's try negative 7. Now, hopefully you guys have learned with me how important it is to have your numbers in parentheses when you plug them in and square them. So since negative 7 is true, when I plug it in, A has to be the answer. Again, you could use the quadratic formula, but I kind of think that's easier to do it like that. 95. Two airplanes left the... It just got like really dark. Two airplanes left the same airport, traveling in opposite directions. One airplane averages 400 miles an hour and the other averages 250. Okay. This is quite a little tricky problem, isn't it? Oh, okay. How can I do this best with you? I'll show you the algebra way, and then like you can decide if you like this way or if you were just going to sit there and kind of guess and check, okay? So one airplane goes 400 miles per hour. So here's 400 miles per hour. So this is the, how do I want to do this? Do you know that distance, maybe we need to start here. Distance equals rate times time. Hopefully you know that. So this is a rate, and we don't know the time. So I'll just put a T. And then the other guy, he's traveling in opposite directions. So we're going to add his distance, and we're going to add his 250. That's his rate, and we don't know his time either. But we do know that together it's 1625. So when we add, we get 650t equals 1625, and divide by 650. And you end up getting 2.5. And that's how many hours it's going to take. Now let's say you didn't know how to do the algebra on that, okay? But you wanted to see if A was the answer. You could just kind of sit here, and if it's a 400 miles per hour, so you could just be like, okay, I don't really know what I'm doing, but I know if it's going 400 miles per hour and I'm going to test A, I have to multiply that by 2.5. And the other guy, if he's going 250 miles per hour, I have to multiply that by my option. And if you get 1625, you know you're right. Now, like if you plugged in C, which is just 5, you're not going to get the right answer. So maybe one way or the other you can do just guess and check, or you can make that equation. 96. Lisa will make a punch that is 25% fruit juice by adding pure fruit juice to a 2-liter mixture that is 10% pure fruit juice. There's a cat tail. Okay, so what she currently has is 2 liters. I'm going to draw a picture of this. I'm hoping that will make sense to you. Okay. So here's 2 liters. Okay, and we don't know what we're going to add. So it doesn't tell us what we're going to add, but we do know that she's going to add something. So let's call it X. Okay. And we do know that she wants to get a new concoction or whatever. So here, this one's 2 liters. It's only 10% fruit juice, so we're going to put a 0.10 inside of there. Here's what she's adding. This is 100% fruit juice, so it's 1.00 as a decimal. And it tells us that she wants her final mixture to be 25%. Now what's hard is this top, like how much is she going to end up with? But it doesn't say she's going to end up with like 4 liters or anything. So the only thing we can do is write 2 plus X up here. Okay? So we need to multiply these together. So we're going to do 2 times 0.10 plus 1.00 times X equals, and this one's kind of hard, 0.25 times 2 plus X. Let's multiply here. 2 times 0.1 is 0.2 plus 1x essentially equals, I'm going to put that in, 0.5 plus 0.25x. The good news is it's just a basic equation now, minus 0.25x. And let's see what we end up getting. That's going to be 0.2. This is going to be 1. That's going to be 0.75x equals 0.5. Oh, I'm running out of room, aren't I? Should have drawn my picture smaller. Minus 0.2 from both sides. I'm just going to kind of go down into number 97, okay? So when I minus 0.2, I get 0.75x equals 0.3. And when I divide, I get 0.4. So X is how much she's adding. So it says how much pure fruit juice does she need to add? She needs to add 0.4 liters, which is option A, of pure fruit juice. 96 might be one of those problems that you kind of look at and you say, wow, that was hard. Yeah, I agree. I wholeheartedly agree. I would probably save a problem like 96 for the end of the Keystones and come back to it and just move on. And don't get too discouraged. There's going to be some that are hard like that, but then there's going to be some really nice ones like 97 that aren't hard. Okay? See how it's a function? Well, let's just make sure you remember from chapter 4 when you weren't with me, a function means X can't repeat. So it says which one is a function? Well, A is not a function because -2 repeats. Okay? B is a function because none of your x's, I'm going to write no x's repeat. C is definitely not a function. Look at all those 4's that repeat. And D is not a function, and it's because of that pesky little 10 that repeats. So B is the option. Guys, look this problem over. Please study it, review it. This is an easy one to get credit for, but it's also easy to forget. 98. Oh, we're almost there, I promise. Look, there's a cattail here. See, he's cheering you on too. Okay, now we'll move him. 98. For which equation graph below are all the y values negative? Well, for a y value to be negative means that the graph is below the x-axis. So as you can see, A is the answer because the entire graph, or you could say line, but it's more proper to say the entire graph is below the x-axis. So that one wasn't too bad, right? That one wasn't too hard. Number 99, two more. What is the domain of the function? I think 99 is a very easy problem, but again, a very easy one to forget. So I want you to understand 99 is super doable, but you got to study this and look it over again, okay? So 99, maybe if we even write number 9, it's easy, but it's also easy to forget. It says, what is the domain? Okay, let's think this through. Domain means x values. So let's write our points out. Oh, these points are hard to see. 1, 2, thank you, Ben. 3, 4. Do you guys see your 4 points? 1, 2, 3, 4. This point is 1, negative 4. This point is 2, negative 5. This point is 4, negative 1. And this point is 5, negative 2. It says, what is the domain? So that's just the x values. So the only one that has the correct option is option D, because it's just the x values that they're listing. Okay, if it was asking for the range, you would put the y values in order. So maybe you want to write that like, if it was range, the answer would be, we have to put them in order. I guess, what would that be? Be negative 1, negative 2, negative 4, and negative 5. I know it didn't ask for that one, but if it was range, that would be our answer. 100. Yay! Okay. Maybe I'm still here with you guys. Maybe I haven't had my baby yet. Who knows? Which of the following graph represents a relation that is not a function? So when you're given a graph and you're supposed to do a function, you want to use the vertical line test. Okay? So what you're going to do is at any time, if you can draw, you want a vertical line, it can only touch once. Okay? So which one is not a function? Well, here's A. A looks like this, right? It kind of goes up like that. Well, look at all these vertical lines. See how they only touch once? That one is a function. A is good. Let's look at B. See how B goes zoop, zoop. See these vertical lines? They only touch once. B is good. Let's look at C. These should also be free problems. See how all these vertical lines only touch once? C is good. Last one, let's take a look at D. Can you see how D is kind of like an oval? Oh boy, don't judge my oval. See how D is kind of an oval shape? See how this vertical line touches 2 times? That's no good. And they were asking us for the one that was no good, so the answer is D. It is not a function. Again, I think this is a very doable one. It's just a little quirk that you have to remember. Not a hard thing to remember, just something you need to remember.